Hello everyone, welcome to my YouTube channel Chemistry Lovers. So today in this video I have shown you another name reaction which is mostly popular reaction known as Simon-Smith reaction. It is mainly used for the preparation of cyclopropane and its derivative from alkene. You can see here I have chosen two alkenes on which if we treat them diiodomethane in presence of zinc copper couple, it will give us this type of three-membered cyclopropane derivative. Three-membered cyclic ring you can see here, and the substituents are methyl and hydrogen. So this reaction contains three steps. I have shown you the mechanism of this reaction given below. Here you can see, I hope you guys can see the mechanism where first an intermediate complex formation takes place. Here you can see zinc reacts with diiodomethane to give zinc iodomethane. It's a complex. You should know the structure of this complex. This is the intermediate complex where zinc being a metal directly attached to the carbon mostly a non-metal. You guys should know carbon is a non-metal but zinc is a metal. So the single bond or sigma bond between them is a polar in nature. On the other hand, iodine connected with the carbon as halogen. So this is the intermediate complex zinc iodomethane. And at the next step, this complex readily attack on the alkene system. Alkene, where the pi bonding pi electron cloud present between the two carbon, where these two carbons are sp2 hybridized. As I have already mentioned that zinc is a metal but carbon is non-metal, so the bond between them highly polar. Hence it will readily attack on one of the pi bonded pi carbon atoms, due to which the pi bond between these two carbon atoms break and attack on the carbon which is attached with iodine. So here you can see the steps. At first, the carbon-zinc bond readily break and capture the pi-bonded pi-electron clouded carbon atom, due to which the pi-bonding pi-electron cloud of these two carbon atoms readily break and connected with the methylated carbon. This is methylated carbon, CH2 group, methylated carbon. So in this way, this methylated carbon gets associated with these two pi-bonding pi electron cloud carbon and form this type of cyclic transition stage. Because zinc being a metal center, the polar bond readily breaks and the carbon zinc bond tends to be break, and the pi electron cloud pi bonded between two carbon also break, and the carbon methylated carbon and this pi bonded two carbon atoms are associated with them with the help of stronger stabler sigma bond. Here I have shown the transition stage. This is cleavage of bond, this is formation of bond. This is also formation of bond, this is cleavage of bond, this is cleavage of bond. So in this way a cyclic transition stage formation takes place during this reaction. And from this cyclic transition stage we get our desired product. This is the cyclic transition stage from which we obtain our desired three-membered cyclic ring. Now here R and R dash can be anything. You can put methyl in place of R, you can use ethyl, you can use phenyl, you can use N-propyl, N-butyl, whatever. R and R prime depends on whether the alkyl or aryl group present within the reactant. So you can use different types of alkyl or aryl group in presence of R. Okay, so this is our final product. So in short, I can tell you the summary of this reaction, that is, from this Simon-Smith reaction we have basically obtained a three-membered cyclic ring, or cyclopropane derivative you can also mention them, because it may be symmetrical or unsymmetrical, depends on the presence of R. If R is symmetrical, then the product becomes cyclopropane and its derivative. Okay, here I have also write some additional example Similarly, cyclohexene also undergoes Simon-Smith and gives this type of compound, and it is also take place on alpha beta unsaturated carbonyl compound. And since it is alpha beta unsaturated carbonyl, so this olefinic unit does not take part into the reaction. Rather, this olefinic unit take part into the reaction. It is free, but it is not free as it undergo conjugation with the carbonyl center. I hope you can write the canonical structure of this system. So I have not shown in here. I have just write this. So this is not free, but this is free olefinic unit, and it is also applicable on the allylic alcohol. This is allylic position. I can see here. This is allylic one. Undergo the Simon-Smith and give this type of product. So in this video up to this, if you have any doubt regarding this topic, then please ask me through the comment section. Thank you.